Hello guys, welcome on Tesla Adventures. Today in this video, I'll be illustrating the graphical problems on kinematics. This is the type 3 and I've seen over the years that many students are facing the problem in this category of questions of kinematics, and I guarantee you one thing, that if you have watched this video completely till the end, then it would be the most satisfying video on the complete internet, which would make you understand the real concept of graphical problems. And I would be illustrating many tricks and tips to solve these kind of problems quickly. And after watching this video completely, I guarantee you that any graphical problem of kinematics from any book, you can easily solve it in seconds. Okay, so let us start this video now. First of all, let us discuss some basics of the graphs. We know that, first of all, let us see the VT graph, velocity time graph. So I have assumed that this velocity time graph is a straight line which is going up. Now you have already studied the mathematical tools and you would have seen that what is slope. So let us first of all discuss the slope in these kind of problems. So if there is a VT graph, velocity time graph, with velocity on y-axis and time on x-axis, then you can see that if it is a straight line or any graph, I have just taken the straight line for example. So if it is any graph, then if you are calculating the slope of this graph, so slope would be tan theta, and tan theta is y upon x. So I have assumed that this is a small element dv, which is a small part of v. This is dv, and this is a small part of x, which is dt, because x-axis is of time, is axis of time. So this is dv and this is dt. So tan theta would be equal to dv by dt. Now we all know that dv by dt is acceleration, and in fact instantaneous acceleration. So I can say that the slope of velocity time graph is instantaneous acceleration. We have already discussed the questions or the equations which are based on time, and we have discussed that the differentiation of velocity time equation is acceleration. So the meaning of differentiation in graphs is slope. So for graphs, I would be talking about slope instead of differentiation, and therefore I can say that the slope of VT graph is the instantaneous acceleration. Now let us talk about the slope of ST, displacement time graph. So this is a displacement time graph, and this is a small part of displacement, which is ds, and again this is a small part of time, which is dt. So this angle is theta, and tan theta would be equal to ds by dt. So the slope of displacement time graph would be equal to tan theta, and this tan theta is ds by dt, and ds by dt is instantaneous velocity. So I can say that the slope of displacement time graph is a instantaneous velocity. Okay, so this was the slope of two important graphs. Now, if you are thinking about the slopes of acceleration time graph, then it may be something, but it is not given any name. Some people call it as a punch, but we are not concerned with that, because in JEE, those questions in which we are required to find out the slope of AT graphs are not being asked. So we are only limited about the slope of displacement time graph, which gives us instantaneous velocity, and the slope of velocity time graph, which gives us the instantaneous acceleration. Now let us talk about the area. So this is a VT graph, and this is a constant VT graph. This black line denotes the VT graph, which is a constant, positive constant, and this is the area. So I have considered a small element like that, and I need to find the area of VT graph bounded with time axis. You should listen very carefully that we are calculating the area of VT graph which is bounded with time axis. So this is VT graph, and this is an element which is touching VT graph from one end, and its other end is touching the time axis. So this is the element. So the area of this element dA would be V into dt. So V dt is its area, and V dt is ds. We all know that V is equal to ds by dt. So ds is equal to V dt. So I can say that the area of this small element gives small change in displacement, and if I integrate the complete section and find out the total area, then that total area would give the total change in displacement. So I can say that the area of velocity time graph gives change in displacement. You should, this is not and, in fact, this is change in displacement. You should note it very carefully that the area of velocity time graph gives change in displacement and not displacement. Okay, now let us discuss about the area of VT graph. We have already discussed that area of VT graph is delta S, change in displacement. Now you can see that this graph is in first quadrant, and in first quadrant both velocity and time axis are positive, which means that particle is moving in positive direction, and hence the displacement is increasing in positive direction. So we can say that the area of VT graph above the x-axis or time axis is positive change in displacement, while the area of VT graph below the time axis is negative change in displacement. It is due to the fact that in this quadrant, this is a fourth quadrant, and in this quadrant, and in this case you can see that the velocity time graph is in fourth quadrant. So fourth quadrant, in fourth quadrant, y-axis is negative and x-axis is positive. So I can say that in this quadrant, which is the graph, VT graph below time axis, in this quadrant velocity is negative. Now negative velocity means that particle is moving in the backward direction, and in backward direction the displacement is increasing in magnitude, although, but the direction of motion is negative. Therefore we can say that the negative displacement is increasing. So the change in displacement would be negative, and the area of VT graph, which is below the time axis, would give the negative change in displacement. But you all know that distance is always positive because it is just the length of path traveled by the body. So in the first case, when the area is above x-axis, then that area is equal to the distance traveled and also the displacement traveled. And when the area is below the x-axis or time axis, then that area represents the distance traveled again, which would be positive, and the negative change in displacement. Okay, so if this is the area, then we can say that the change in displacement is plus positive of this area, and the change in distance is positive of this area. But if this area is below the time axis, then we can say that the change in displacement is minus of this area, and again the change in distance would be positive of this area because distance cannot be negative. Now if in a single VT graph there is both type of graphs, one is above x-axis and one is below x-axis, and the area of graph above x-axis is A1 and the area of graph below x-axis is A2. So we can say that the displacement of this motion would be plus A1 minus A2, because this area would represent positive change in displacement and this area would represent the negative change in displacement. So the body is traveling in forward direction during this motion, and during this motion the body is traveling in the backward direction. So displacement is decreasing in this motion. Okay, or we can say that displacement is increasing in negative direction. So the net displacement of this complete motion would be a1 minus a2, although the distance would be a1 plus a2. It is due to the fact that distance is just the length of path traveled. So if a body is traveling in forward direction and then it makes a U-turn and it starts to travel in the reverse direction, then also you can see that the distance traveled will be increasing always. Now, let us discuss more basics of graphical problems. You can see that this is a AT graph, acceleration time graph, and the area of a small element area, which is this element is touching the acceleration time graph from one end, and the other end of this element is touching the time axis. So the area of this element dA would be A into dt, and we know that A is equal to dV by dt, so A dt would be equal to dV. So I can say that the area of acceleration time graph bounded with time axis represents the change in velocity and not a speed, obviously, because acceleration is not the rate of change of speed. In fact, it is the rate of change of velocity. Now again, if this area is above the x-axis, then change in velocity is positive of area, and if this area is below x-axis, then change in velocity is negative of area, which means that if this graph is above x-axis, then acceleration is positive, and positive acceleration means that the acceleration and velocity are in same direction. And if this graph is below x-axis, then acceleration is negative, and negative area represents the fact that acceleration and velocity are in opposite directions. So if in a single graph, some of the graph is above x-axis and some graph is below x-axis, so the net change in velocity would be a1 minus a2. Now it is very important to note that I have taken the constant graphs to represent the area, but this fact that area of acceleration time graph gives change in velocity is valid for all kind of graphs, whether it is a straight line, whether it is a constant, whether it is a parabola. AT graph might be anything, its area would always represent the change in velocity, provided that you are calculating the area which is bounded with graph and time axis. Okay, so these same thing goes with velocity time graph, that I have just taken for ease of illustration that v is constant. It doesn't mean that this concept is valid for only these kind of graphs. This concept is valid for any kind of velocity time graph. Okay, now we can memorize this concept very easily, that we can draw a hierarchy in our mind, that on the top it is acceleration time graph, and in the mid it is velocity time graph, and at the bottom it is displacement time graph. So if we need to find out velocity from displacement time graph, we need to go up and we need to find out the slope. And again, if we need to find out the acceleration from velocity time graph, then again we need to go up and we need to find out the slope. Now in just reverse order, if we are going in downward direction, then if we need to find out the velocity from acceleration time graph, then we need to find out the area of AT graph, which would give the change in velocity. And if we need to find out the displacement from velocity time graph, then we need to find out the area of VT graph bounded with time axis, obviously, and it would give the change in displacement. Now in the curriculum of JEE, although most of the questions are being asked which are based on straight line and parabola, but obviously any kind of graph can be given in the question. But we are generalizing some things for graphs which are parabola and straight line. So let us first of all discuss the fact that if there is a graph which is a parabola opening in the upward direction. So let us assume this is a parabola whose base is this, and it is opening in the upward direction. So you can see that y is equal to ax square. This is the equation representing this parabola. So if I differentiate this equation, then you would be getting y is equal to 2ax. Okay, so this would be a straight line which is passing through origin and going up. So you have to remember one thing, that if we differentiate a parabola whose mouth is opening towards positive y-axis in the upward direction, then its derivative graph with x would be a straight line which is going in the upward direction. Now if the base of the parabola is at origin, then this straight line would be passing from origin. And this also is valid for in the reverse direction. That if you are integrating a straight line which is going up, then it would be giving a parabola which is opening up. Okay. Now what if this parabola does not have its base on origin? So this is a parabola which does not have its base at origin, but it is passing through origin. So this parabola has an equation of y is equal to ax square plus bx. And if we differentiate this kind of parabola, then you would be getting y is equal to 2ax plus b. So this is again a straight line which is going up, but it is not passing through origin because this parabola does not have its base at origin. So if a parabola is opening in the upward direction, it is definite that its derivative would be a straight line going in the upward direction. And if the base of that parabola is at origin, then that straight line, which is the derivative of the parabola, would be passing through origin. And if the parabola does not have its base at origin, then that straight line which is going up would not be passing through origin. Now if this parabola is opening in the downward direction, so let us assume the equation that y is equal to minus ax square. So if we differentiate this equation, then it would be y is equal to minus 2ax, and hence it is a equation of a straight line which is passing through origin, and this line is drawn in fourth and second quadrant, because if x is positive, then y would be negative and vice versa. So if parabola is opening in the downward direction, then there would be a straight line which is going down and it would be passing through origin. And reverse is also true for integration. And if this parabola is not having its base at origin, then this is the equation of parabola which is not having the base at origin, but its mouth is opening in the downward direction. So its derivative would be a straight line which is going in the downward direction and starting from a point of minus b. Okay. Now if this is a parabola again whose mouth is opening in the downward direction, but its base, initially its base was in second quadrant and now its base is in first quadrant. You can find out the base by differentiating this equation with respect to x and equating it to 0, because at base the slope dy by dx is 0. So if we differentiate this equation with respect to x and equate it to 0, then x coordinate would be positive, which means that this parabola is passing through, is having its base in first quadrant. Okay, so this is the parabola. Now if we talk about, you can also see that if you are substituting y is equal to 0, then there would be two values of x. So you can see that this graph would be cutting x-axis two times. So one is at x is equal to 0 and other is at x is equal to b by a. Okay, now if you differentiate this equation, then you would be getting this equation, and this is again a straight line which is going in the downward direction, but it is starting from positive y-axis. Now if there is a straight line which is starting from b and it is going in the upward direction, then its equation is this. And if you differentiate this straight line, then you would be getting a positive constant. Okay, so if we find out the derivative of a straight line going up, then we would be getting a positive constant. And if this straight line was starting from origin, then also this b would be 0, but its derivative would be same. So for straight line, it does not matter that whether it is starting from b or from some other point or from origin. It is definite that its derivative would be a positive constant if it is going up. And same goes in the reverse direction for integration. Now if this straight line is going down, irrespective of the fact that it is passing through origin or not, then its equation would be like that, and its derivative would be a negative constant. Okay, so to summarize this logic, we can see that if we differentiate a parabola which is opening up, then we would get a straight line going up, and if we differentiate a straight line going up, then we would get a positive constant. Now if we integrate the positive constant, then we would get a straight line going up, and if we integrate a straight line going up, then we would get a parabola opening up. Now if we differentiate a parabola opening down, then we would get a straight line which is going down, and if we differentiate a straight line going down, then we would get a negative constant. Now if we integrate the negative constant, then we would get a straight line going down, and if we integrate the straight line going down, then we would get the parabola opening down. So now now we move on the concept illustration problem to explain these concepts very easily. Now in this question, we are given with a velocity time graph, and it is also given that at t is equal to 0, s displacement was 0. This is a velocity time graph of a particle which is moving on x-axis. So it is a rectilinear motion. Okay, now we have to draw the acceleration time graph and displacement time graph. So let us start with acceleration time graph. So first of all, we know that while we draw any graph, then it is very obvious that time axis would be same. So we have to draw the time axis as same, which is given in the problem. So you can see that this is a AT graph, which is A is in meters per second square and T is in seconds. So this is a AT graph, and we have to draw the time coordinates same. So this is 10 and this is 20. Okay, so let us draw it same. This is 20. Now you can see that in time 0 to 10 seconds, you have to choose the slots of time in such a way in which a single graph is given. So we cannot choose the slot as 0 to 20 because there are two different graphs in this slot. So we have to choose the time slot from 0 to 10. So in 0 to 10 time slot, you can see that VT graph is a straight line. Graph is a straight line, and hence therefore we have to differentiate this graph. So hence we can say that AT graph would be a positive constant, is a positive constant. Why we are saying positive constant? Because VT graph is a straight line going up. So you can see that the acceleration would be the slope of VT graph. Slope of VT graph. So the slope of this VT graph in 0 to 10 would be 5 upon 10. So acceleration would be 5 upon 10, which is 1 by 2. So acceleration is plus 1 by 2. So we can draw the AT graph. This is plus 1 by 2. This is AT graph. Okay. Now in time slot of 10 to 20 seconds, VT graph is a straight line going down. Okay, so AT graph would be a negative constant, and the acceleration would be, the magnitude of acceleration would be the magnitude of slope. So the magnitude of slope would be again 5 by 10, which is 1 by 2. So the AT graph acceleration would be minus half. So it would be a negative constant and it would be minus half. So this graph would be like that. This would be a negative constant. This is plus half and this is minus half. So this is the acceleration time graph which we have drawn from this graph. Now let us talk about the displacement time graph. Now again, to plot the displacement time graph, we have to plot the time axis, which is same. So let us draw the time axis same. So this is the graph. So let us draw the time axis. And this is displacement taken in meters and this is time taken in seconds. So you can see that in 0 to 10 seconds, VT graph is a straight line going up. This is a straight line going up, and ST graph would be a parabola opening up. Okay, so ST graph would be a parabola opening up. Now this parabola would start from S is equal to 0 and T is equal to 0, which is the origin of this graph, because it is given in the question. So initial starting point would be provided in the question, and the area of this graph, A1, let's suppose this is A1. So A1 is half base into height. Base is 10, height is 5. So it would be 25. So area of this graph is 25 and this area is above the x-axis. You can see. So we can say that this area A1 is equal to the positive change in displacement. So delta S would be 25 and initially S was 0. So this graph would be a parabola opening up and going in the upward direction. So we need to find out three important things about parabola, that towards which axis it is opening. So we have already written that it is opening towards positive y-axis, which is the displacement axis. It would be going up till 25 because initially it was 0 and delta S is 25. And finally the base of the parabola would be at the point where velocity is 0, because this parabola is a ST graph and the base of ST graph, or the base or the slope of ST graph is 0 where velocity is 0. So we know that at base of the parabola which is opening up, the slope is 0. So the base of parabola would be at origin. So parabola base would be at origin. Okay, so this is a parabola which is opening in the upward direction and going till 25. Okay, so this is 10 seconds. So this is the parabola. Its base is at origin. Okay, now from 10 to 20 seconds, you can see that VT graph is a straight line going down. Okay, and therefore ST graph will be a parabola opening down. But you can see that again the area of this graph is above the time axis. So this area is A2, and A2 is also plus of 10 into 5, which is 25. So the change in displacement delta S2 will again be 25, and initially S was 25, and there is a change in S which is of plus 25. Therefore this parabola will reach the 50 mark. So this is the 50 mark, and this parabola reaches a 50 mark. Now this parabola is opening in the downward direction, but it is going up, and its base would be at a point where velocity is 0. So velocity is 0 at 20 seconds. So its base would be at 20 seconds. So this parabola would be traced like that. Okay, so this is the correct displacement time graph of this problem. Now in this problem, you can see that this is a VT graph, and we have to plot the acceleration time graph and displacement time graph by this VT graph. It is given in the question that at t is equal to 0, initial displacement was minus 10. So this would be used in the next part, in which we would be drawing the velocity time graph in displacement time graph. But initially we are concerned with the acceleration time graph. So first of all, we have to mark the time axis same, and now we will consider the time slots having a single graph. So let us write the time slot 0 to 5 seconds. So in 0 to 5 seconds, you can directly see that the VT graph is a straight line which is going in the upward direction. So the acceleration time graph would be a positive constant. So this is a positive constant. And the slope of this VT graph would be slope of VT graph is equal to this y upon x. This is 10 upon 5. So this is equal to 2, plus 2. So the acceleration in this time slot is plus 2. So we would draw this graph of A, and this is plus 2. So this is the graph of A. Now in the second time slot, which is from 5 to 10, you can see that V is positive constant, and therefore its derivative, which is AT graph, will be 0. A would be 0 because velocity is constant. So VT graph would be a 0. In fact, it is a line which is on x-axis, like that. And in the interval from 10 to 15, you can see that VT graph is a straight line which is going in the downward direction. Therefore, AT graph would be a negative constant. Negative constant. Okay, and its magnitude of slope of VT graph is, this is 10 and this is 5. So this is plus 2 magnitude, while the slope is minus 2. Therefore we can say that acceleration would be negative 2. So it would be like that. So AT graph would be minus 2 in this time slot. And in the last time slot, which is from 15 to 25, we can say from 15 to 25. VT graph is again a straight line going in the downward direction, so acceleration would be negative constant, and therefore you can find out the magnitude of slope, which is 5 upon this is 10. This is 5. We are finding out the magnitude only, so you need not to take this negative sign. So this is 5 and this is 25 minus 15, which is 10. So this is 5 upon 10 and it is 1 upon 2. But we are concerned with the slope. So slope would be minus half. So acceleration in this time would be minus half. So this is minus half and the AT graph would be like that. Okay, so this is the acceleration time graph. Now let us draw the displacement time graph, and to draw the displacement time graph we have to draw the time axis same, so which I have already done to save the time. Now you can see that it is given in the question that initially displacement was minus 10, therefore we can say that this graph would start from minus 10. Okay, this would not start from origin. Now in time slot of 0 to 5 seconds, this VT graph is a straight line going up, therefore ST graph is a parabola opening up, which we have already discussed. Parabola opening up. Now you can see that this area A1 is equal to half 10 into 5. So this area is 25 and this is positive change in displacement. So if the graph is starting from minus 10 and a change of displacement of plus 25 has occurred, so the graph will move in the upward direction and it will move till 15, because you can see that 25 minus 10 or minus 10 plus 25 would be plus 15. So this would be a parabola opening up. This parabola will be going in the upward direction and the base of this parabola would be at a point where velocity would be 0. So you can see that velocity is 0 at t is equal to 0. So the base of this parabola would be at t is equal to 0, which is at minus 10. So let us mark another point of this is plus 15, or let us mark this minus 10 accordingly. So this is minus 10. Let us suppose that this is minus 10 and this is plus 15. So this would be a parabola whose base would be at this point minus 10 and it is going till 15. This is plus 15. So this is the parabola. Okay, now let us consider the second time slot, which is from 5 to 10. 5 to 10 velocity is positive constant. V is positive constant. So if we are going in the downward direction towards displacement, so we can say that ST graph would be a straight line going up. Okay, going up. And the area A2. So A2 would be equal to, you can see that this is 5 and this is 10, so A2 would be 50. So the change in displacement is plus 50 and initially the body was standing at plus 15 and a change of plus 50 occurred, so it would be now at plus 65. So 65 and the graph would be a straight line, and this straight line would be going in the upward direction like that. This is the graph. So let us see that if this angle is theta, so you can see that this tan theta would be the slope of ST graph, and this is the velocity. So velocity is 10 in this interval. So this 10 theta is 10. Now this A3. Now we are taking the time slot 10 to 15. In 10 to 15, VT graph is a straight line going in the downward direction. So ST graph would be a parabola opening down. And the area is again above the time axis. Therefore this area A3, which is half 5 into 10, which is 25, would represent the positive change in displacement. So the body is standing at 65 and a positive change of 25 occurred. So it would be now at 90. So let us mark a 90 point. So this is 90 and this. Now this parabola is opening in the downward direction, but it is going in the upward direction, and its base would be at a point where velocity is 0 in this interval. So in this interval, velocity is 0 at t is equal to 15. So this parabola would be opening in the downward direction, moving in the upward direction, and its base would be at t is equal to 15. Now for the last time slot, which is from 15 to 25. So this is 15 to 25. So in 15 to 25, again VT graph is a straight line going in the downward direction. So ST graph would be a parabola opening down. So this is ST graph, which is a parabola opening down. Okay, so this parabola, now area of this graph is A4, and area A4 is equal to half base is this 10 and this is 5. So half base into height, so it would be 25. You can see that this is base is 10 and this is 5. So A4 area would be 25, but this area is below the x-axis, below the time axis, so it would be representing the negative change in displacement. So it is minus of delta S. So the body is standing at 90 and a negative change of displacement occurred of 25. So 90 minus 25 would be 65. So this graph would again come to 65. And this would be a parabola opening in the downward direction. Now this graph has to come down, therefore this parabola will move down, and this interval, in this interval 15 to 25, the velocity is 0 at t is equal to 15. Therefore this parabola would have its base at t is equal to 15. So this parabola would share a common base with this one, and it would move down like that. Okay, so this is the VT, this is the displacement time graph. Now let us also find out this time t0, where this graph would cut the time axis. So we know that, let us use next page. We know that in the time interval of minus 10, in fact 0 to 5, in this time interval, the acceleration was in 0 to 5, acceleration was plus 2. So in 0 to 5, A was equal to plus 2 and it is constant. So the equations of motion are valid. Equations of motion are valid. So let us use the second equation, S barabar, S is equal to ut plus half a t square. So u is the velocity at t is equal to 0, which was 0. So u is 0. And the acceleration is plus 2. And you can see that initially this body was at minus 10. And when it is crossing, when this graph is crossing the time axis, then the displacement of body became 0. Which means that body has traveled from minus 10 to 0. and therefore it has traveled in the positive direction by a displacement of plus 10. So S would be equal to plus 10 because S is displacement traveled. Okay, so plus 10 would be equal to half A is 2 and T square. So T would be equal to root 10. So this is the T naught which we are finding out. So this time T naught is equal to root of 10 seconds. Okay guys, so I can sense that after watching this video completely, you would be getting a complete sense of feeling for the graphical problems, and I guarantee you that now if you have watched this video carefully and completely, you would not be facing any kind of problem in any type of graphical problem of any book of physics which is in the curriculum of JEE Advanced and Olympiad. So this was the video, and probably this is the best video on the YouTube on graphical problems. Let us see what do you think. Please tell me in the comment box. Thank you.